Welcome back to Introduction to Programming. This is video 14 in our series, and my name is John Duane. Today we will continue our coverage of controlling program flow with looping. First, I'll quickly review what we did last time, and then we'll dive into our example program, which demonstrates a very practical application of looping, our zip code search program. So here's what we looked at last time. Now, if you've not already watched video 13, you should do so now because this video is going to refer to that one several times. We have a for next loop and 3 do loops. You may say to yourself that they all seem to be doing pretty much the same thing with only minor differences, so why do we need so many looping techniques? Well, the reason is that they fit into different situations. Let's talk about them one at a time. The for next loop uses the counter, in this case the variable I. It also has a very explicit stopping mechanism, this like 220 in this case. This technique is perfect for situations where you know ahead of time how many iterations of the loop you want to perform. On top of that, you may be able to take advantage of the counter variable and use it for something else. The best example of that is when working with arrays, which we'll cover in a future video. But in that case, you need to supply each array element with an index number. If you're using a for next loop to fill the array, the counting variable is normally also used as the array index number, so very handy. Next, we have the do until active cell equals empty loop, which is a great technique when reading data from a worksheet. Frequently, the data you are interested in is in a column or row, and you want to stop when you hit the end of the data. Now, this technique is excellent for that as long as you don't need an array index number. If you do, the for next loop might be the better choice. The do loop does not need to know ahead of time how many items you're going to be looping through. And then we have the do while loop. That's this one here. This is very similar to the do until loop, and often they are used interchangeably. The only real difference is that the do while loop continues as long as a certain condition exists, while the do until loop continues until a certain condition changes. The deciding factor in choosing the technique is usually which one will be easier for the person in the future who might have to modify or maintain this code. And then finally, we have the do loop with the test coming on the last line down here, not on the first line. This is the looping structure to use when you absolutely want your instructions to be executed on the first item, regardless of the test. The test would apply to the second and subsequent items. So there's plenty of times when that'll be the perfect choice. Okay, so now we're going to look at our practical example. Often loops are used to process large data sets, and we have one of those here in our example. I downloaded from the web a list of zip codes with all sorts of information attached to each one, such as the city it belongs to, latitude and longitude, all kinds of things. And I copied all that data onto sheet 2 in our workbook. Now, the purpose of the program is to search for the zip code of a city. The user supplies the city, the program returns the zip code. All right, so let's just take a look at that code. Got that off here in module 2. All right, so not that long. Let's take a look at it. We have a variable that will hold the name of the city that we're looking for. We have these 2 variables, which are data types. These will be used to measure the length of time it takes to do our looping. Here we have an input box where we get the name of the city from the user, goes into the variable. Here we begin our timer. Here we'll start the loop. It's a do until active cell equals empty loop because we're going to be going down a column. We're going to be going down column A, so we're starting here in A1. And each time we loop, we're going to be looking over 2 columns. That's this offset 0 rows, 2 columns. So we'll be looking in column C to see if the value in column C equals the value in our variable string city. If it agrees, then bang, we end the timer. We print out the city that's in our variable, and then over here active cell value, that will be the actual zip code itself. And then right below that, we'll print the number of seconds that the search took, and that'll be determined by subtracting the beginning time from the ending time. And then we exit the loop. No reason to continue on. It'll be pointless since we've found our item. So no reason to go all the way to the end of the column if we don't need to. And then we're done. So let's run this a few times and let's see what we get. So I'll put in the name of a city. We'll start with Boston, where I live. And there we go. Zip code in Boston. This is one of them. This is the first zip code that it came to in the list, 02108, and that took 0.3 seconds. So let's take a look at sheet 2. And it didn't take very long because it only had to go down to row 614. So there's Boston, and there's the zip code. All right, let's run another one. All right, let's try Pittsburgh. I have friends in Pittsburgh. What's the zip code there? Takes a little longer. 15201. Okay, that took 2.3 seconds. Not very long, 2.3 seconds. If we go to the code, well, that took a little longer because it's down almost in row 6000. All right, so that makes sense. Let's try another one. Well, Boise. We're sort of working our way west. It's chugging away, and the zip code in Boise, 83701. That took 7.8 seconds. Oh, that's quite a while. What row was that on? Oh, that's all the way down in row 36,269. All right, let's try one more. Sacramento. Hopefully I spelled that right. And I didn't, so let's try that again. It just went all the way to the end and gave me nothing. Let's try that. There we go, Sacramento. 17968, only 2.8 seconds. So what row was that in? It's only in row 7000. Oh, interesting. Sacramento, Pennsylvania. I was going for California. Let's try San Diego. There can't be more than one San Diego. I'm thinking this will take longer than 7 seconds. And there we go, 8 seconds. And what row is this in? 34,000. Okay. All right, I think you've got the idea. To wrap up, this looping program is a good example of a simple linear search routine. We call this a linear search because it searches in a straight line. That is, moving down the column one item at a time. For small data sets, this is a perfectly acceptable search technique. In later videos, we may cover more advanced search algorithms, such as the binary search, which is much faster given the right conditions. So that's it for today. I hope this was helpful. Please subscribe to this video series and please write comments about anything that wasn't clear. I monitor the comments and I will definitely respond. See you next time.